Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 9th grade topic, adding and subtracting radicals. Now, if you're new to my channel, I'll be putting timecodes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any question about what you see here today or even your own homework, feel free to put it in the comment box below or visit me on my Facebook page at Tutor Me Sempai and tell me about it there. Today should be a short one, so hit that like, smash the subscribe button, and let's get started. Although adding and subtracting radicals is pretty simple, there's still some things you need to know first. And those things are what a radical is, how to simplify your constant radicals, and how to simplify your variable radicals. If you have any questions about any of those three, I have a video on each one of them you can find up here. If you click on any of those, you'll be able to get the information you need that makes this video make more sense. So check out those videos and then come back to here to figure out how you're going to add and then subtract your radicals. So once you get all of that down pat, the process for adding and subtracting radicals is going to mirror your process for adding and subtracting variables actually. If you know how to add something like this, I assure you, you know how to add your radicals. And that's because when you're adding your variables, you do something called combining like terms. You see, this is similar to this, but it's going to be something different from this, right? These two are not the same, although they have an x, same base. This is not the same unit as this. This is an x, this is an x squared. So you wouldn't add this to these. These are the same, this is different. Adding like terms or combining, because you can add or subtract, is going to be the same process you're using for your radicals. So if you have something like this, you're going to combine it just like you would your x's. So this is going to be, well, an understood one up front of both of these. So you add the coefficients. You add the coefficients and then you write the radical as it is. Similar to how you would for x's, right? If you have two x's, and you want to combine them as an understood one, and then you add the coefficients, and then you leave your x alone. You see, it follows the same exact pattern. So if you know how to combine like terms like you would for variables, you're going to do the same exact thing for your radicals. And this is also going to be true for subtraction. So if this was a 3x and that was a 2x, if you had to subtract these two, 3 minus 2 is going to give you 1x. So you can just say x. Likewise for your radicals. 3, 2. If you have something like this, as long as you have like terms, or in this case, like radicals, then you can just subtract the coefficients. And that's just going to be a 1 square root of 2. And you don't even have to write the 1 there. You can just write square root of 2 because this is 1 times square root of 2 and this is an understood 1. So you don't have to worry about that. But the important part is you have to combine like radicals. So remember, I said when you had to combine like radicals, this was not the same as these two. Similarly, if you have something like, going back to our example, if you had something like this, although the 2 is the same, if you have a cube root, this is not the same as these. You can't combine these, although the 2 is the same. We're not looking at what's under the radical only. You have to look at what's under the radical and the type of radical. It's the radicand and the index that both have to match, just like you do for this, right? You're looking at the base and the exponent here, right? You're looking at the base. So you can have a y here with the same exponent of 1 and you still couldn't combine those. So you look at the base and you look at the exponent. Likewise, you look at the radicand and you look at the index. If they are different, you don't combine them. And I say that loosely because there will be some cases that you can combine. However, there's some work that you have to do first. But when it boils down to it, the final combination of whatever you're working with has to be the same radicand and the same index. So let's look at this example here. You have 10 times the 5th root of 8 minus 3 times the 5th root of 8 plus 5 times the square root of 5. I want you to combine your like terms in order to add and subtract these radicals. First thing you have to do is identify your like terms, your radicands. Are they the same? Well, these are the same, but this one's not. So we're automatically excluding this. We're not going to be able to combine this because your radicands are not even the same. Next, we look at our index. Our index is the same for these radicals. Yes. So because our indexes are the same, we can combine our coefficients. So 10 minus 3 is going to give us 7. And then we just plop our radical right next to it. Make sure you're keeping your index. Don't lose that index. You're keeping your index. And you see we just write that over. And now we bring that down because we can't simplify this anymore without getting into decimals. If we want to keep it in its full form, this is as far as we go. When we're adding and subtracting, you have to focus on like terms. No like terms, no combinations. I don't want you to think that you can only do it for your constant radicals. It's going to be true for your variable radicals as well. As long as you have the same radicand and your same index, you can add the coefficients. So this is going to be an understood 1, that's a 5. So you see we have the same radicand and index. We combine these to be a 6, 6th root of x to the 15th. The same exact process whether it's a constant or a variable. Now remember, I said there will be some cases in which you can combine them, although they might have something different under the radical. So your radicand might be a little bit different. It's never going to be the case where you can combine them when they have different indexes. However, when they have different radicands, that is something that's possible. And it's possible only because we know how to simplify. Sometimes you have to simplify first in order to see if you eventually end up with the same radicand. If you simplify something first and you end up with the same radicand, then you can combine it. However, if you can't simplify or you simplify and it still doesn't have the same radicand, then you still can't combine it. So in this case, at first glance, it looks like we have the same index, but we don't have the same radicand. So you might be tempted to say you can't combine these. However, we know that this can be simplified based on our second video on how to simplify our radicals, right? If you don't see it how it is, we can rewrite this to 8 times the square root of 9 times 3, right? And then we know that we can break these up. 8 times the square root of 9 times the square root of 3. I'm going to put these in parentheses so we know that it's the same thing we're multiplying. And you know that this is actually going to be a constant. So this is 8 times 3 times the square root of 3. So if you didn't see that this square root of 27 can be simplified to this, then I recommend once again going back to my video on how to simplify radicals before you really dive into this, because this is something that they expect you to do. So I'm going to erase this and I'm going to move my answer up and assume that we already knew that the square root of 27 can simplify to this. So now that we've simplified our square root of 27 into 3 times the square root of 3, we can then multiply this 8 times this product here. And when we do that, we get 24 square root of 3. So now we have 24 square root of 3. We can bring this down. So it's going to be 3 square root of 3 here, 3 square root of 3 here. And now we have not only the same index, but the same radicand. So now we can combine our coefficients. 3 minus 24 will give you a negative 21. And that's going to be square root of 3. This is your final answer. The same thing is going to be true for your variable radicals as well. Sometimes you have to simplify first. So although they have the same index, they don't have the same radicand. So which one of these can we simplify? Well, this one. We know that we can simplify this by taking our index and dividing it into our 10. That was our shortcut that we talked about, right? So how many times does 3 go into 10? 3. So that means we're going to have 3 x's on the outside and we have 1 x left over. So when we do that, we see that we indeed have the same index and we have the same radicand, so now we can combine our coefficients. However, this might not seem as straightforward when you're trying to combine this. So if you have an issue trying to combine these, make sure that you factor out your like terms. You can always factor out your like terms. So you see these are your like terms. So when you factor them out, I'm gonna put them on the end and I'm gonna have our parentheses up front. So when I factor that out, we have the cube root of x out here, and what's left behind? We have an x cubed minus, there's an understood 1 here, 1. This is your final answer. X cubed minus 1, in parentheses, multiplied by the cube root of x. So I hope you're following today's video, and I hope you realize that when you're adding and subtracting your radicals, it's just as simple as if you were adding and subtracting your variables. So if you know how to combine your like terms, you know how to add and subtract your radicals. If you have any question about what you saw today or even on homework, remember you can put it in the comment box below or visit me on my Facebook page at Tutor Me Sempai and tell me about it there. If you haven't done so already, remember to leave a like. It really helps the channel by letting YouTube know that you found this video helpful, and it can also be helpful to somebody else. So hit that like button, smash the subscribe button, hit the notification bell, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping to help with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.